Hello, today I would like to introduce you to a new mechanism I have introduced into our software packages called MIPSS. MIPSS stands for Multiple Instances for Parallel Spectrum Simulation, and it will help you to speed up your spectral analysis if you have many spectra to analyze in a short time, or to speed up some design problems on computers which have multiple cores. You can easily get today computers with 6, 8, 12, 16, or even 32 cores for relatively low prices, and we adapted our software to make use of that. The easiest way to make use of the new MIPSS mechanism is to use it in batch control. I have explained the batch control mechanism in a previous video tutorial. Here I just repeat one of the examples. It's a thin film analysis, a single layer of an oxide deposited on glass. And if you measure the sample at different positions for homogeneity control, you can collect all the measured spectra in the batch control window. That means a table of input spectra, and then if we press go, the code software in this case does the analysis point by point, and once the analysis is finished, it will store the results in the table and then display the table values here in these graphs. We can show the status bar to follow the progress of the fit, and you can see for each point, for each individual fit, our code takes a few seconds, almost 10 seconds. So for the more than 30 points here, we have to wait a few minutes in order to get all the results. And of course, this is a situation where you would like to see the results right now, or at least faster. And since the computations are done point by point, they can easily be done in parallel. You just have to organize this. And the new MIPSS mechanism can do that for you rather easily. But let's first wait until all the results are finished so that we can see the thickness profiles and the profile of the refractive index value here at 633 nanometers. Okay, here's the final result, the full thickness profile and the profile of the refractive index. And let's now speed up this computation. Actually, the code program that does the fitting here can use only one core at a time. So in order to have parallel fits, we have to start the code program several times. This first instance that we have here will just manage to control some more instances which run in the background. Here on my laptop I have 4 cores available, so we can do 4 fits in the background at the same time. And I can set this with in the new menu item called MIPSS. And we set the number of worker instances, or these are called server instances in the MIPSS language. We need 4 in the background. Sorry, it's moved a little bit outside. I have to move it in. So the 4 code programs that run in the background are now started, which takes a while. But you only have to do that once when you set up the batch control. If you fit sample by sample, they stay in the background, and they can just stay there all the time. You don't have to generate them newly. Okay, if you want to do a batch fit, you have to copy the analysis method to all the instances, which is done with the command copy client configuration to all instances. So all the code instances in the background will get the same optical model. And in this case, they will also get the same set of input spectra. So they are now there in the background. Let's show one of them. with the command MIPSS show first instance. It will show up here. So actually the optical model is exactly the same, even the batch control content is the same. And there are 4 of those code programs running in the background. Let's hide it. Let's now go to the batch control window. In the managing code software, I will delete the results here so that we have an empty table. And then basically what we do is just say go MIPSS instead of go, which means tell all the subprograms to do their fitting work. So the main instance of code here is not doing any fitting by itself. It just waits for results to arrive. And you can see that we have already done 4 fits. And as soon as one of the background instances is ready with fitting, it will get the next task. So the managing code instance here will keep all them busy as long as there are new spectra to be processed. And compared to the speed that we had before, where we had only be using one core, you can maybe already feel now that this is faster. Actually, I measured the time carefully, and it's pretty much exactly 4 times faster than what we had before. There's a tiny overhead of starting fits and picking up results, but that is negligible here in this case. So the final result will be ready pretty soon. Of course, each instance that runs in the background will not have the full set of results. It will only have 1/4 of the results. But here, this managing instance will have a full set of results in its batch control window that you can use as before. So the fits are now ready. No new results. We can inspect the batch control window here, and it is filled with full numbers as if we had used 1 core before, but now the results come from 4 cores. If you have a powerful machine, in this case with let's say 16 cores or 32 cores, you can have all the results at 16 times the speed or even 32 times the speed. This was the application of MIPSS for batch control operations. There's a new mechanism called bulk analysis, which I will explain in one of the next tutorials, which is similar, but which is dedicated to a certain problem that you have in real life spectroscopy. So wait a few days and then that will be out too. Thanks for today. Bye bye.